Good evening, earthquake listeners, earthquake fans, people interested in the truth and thoughtful research. I love it. Thank you for watching my video and supporting me. I want you to take a look at this map. This is provided by Earthquake 3D. These are all earthquakes over 4.5 magnitude in the last 7 days. This is going around the globe, around the edges of plate boundaries. And you'll see Europe is filled in with a bunch of 4s and 5s. You'll see Indonesia, Papua New Guinea, the Fiji Islands, everything filled in, 4s, 5s. Moving up north through the Philippines, Taiwan, Japan, 4s, 5s, 4.5, 5.2, 4.5, 4.7, 4.7, 4.8, 5.1. Moving into the Aleutian Island chains, the Kuril Islands off the coast of Russia, 4.5, 4.5, 5.4 in Alaska, 5.2. And then when you get into British Columbia in good old United States of America, it's silent, nothing. Everything is small, nothing over 4.5, which is pretty interesting. And then even when you move further south, south of Mexico and the Central America and the South America, you see the same thing. 4.5, 5.2, 4.7, 4.6, 4.5, 4.5. So, just looking at this map, you've got to go ahead and just expect there will be an increase in energy along the Pacific Northwest into California, Baja California, into Mexico, over the next 7 days, okay? So I would expect that to happen. Now, want to get into something really deep, is Antipodes and earthquake forecasting. How can you forecast an earthquake with Antipodes? Got to give credit where it's due. Shout out to Oregon State University. Robert O'Malley and his team. They performed a study, and there's clear evidence that exists. This is from the study. Clear evidence exists that demonstrates earthquakes of 6.5 or larger trigger earthquakes of magnitude 5.0 or larger. And this is based on seismic data over a 44-year span from 1973 to 2016, and the 3 days following one large 6.5 or greater earthquake. Now remember, in one of my previous earthquake forecast videos, I mentioned a 72-hour span being the most accurate time frame on seeing one earthquake event and then making a determination that you would expect another earthquake of similar size to happen. And that 72-hour span, that was just based on my personal history of analyzing earthquakes and seeing how they travel along the plate boundaries, and also being inspired through the genius of Dutch sense. So I did mention a 72-hour time frame being the most accurate time frame, and I'm so glad to stumble upon this research. This is the first time I've read this coming from Oregon State University's research team, because it confirms my beliefs to a certain extent. Now back to the research. To more clearly connect the smaller earthquakes over a 3-day period with the large event, these Oregon State University scientists, led by corresponding author Robert O'Malley, these scientists had a control group of 5,355 3-day periods that did not include a large 6.5 event. So basically, 5,355 times they analyzed earthquakes over a 3-day period that had nothing to do with a large 6.5 event, and they compared that to 5,355 3-day periods that did include a large earthquake event over this 44-year period. And they went on to conclude that the larger the earthquake magnitude was, the more likely it was to trigger another earthquake. And even deeper, the study concluded that these large earthquakes are also most likely to induce another earthquake within 30 degrees of the original earthquake's antipode, or the direct opposite point on the other side of the globe. So, with that said, if that 44-year period is accurate, if the research is true, and you got to give them the benefit of the doubt. These are scientists from Oregon State University. Oh, I'm sorry, there's some collaborators as well. Michael Barenfeld of the College of Agricultural Sciences, Debashis Mondal of the College of Science, and Chris Goldfinger of the College of Earth, Ocean, and Atmospheric Sciences. So those are the collaborators of this study that analyzed a 44-year span from 1973 to 2016. Assuming we give them the benefit of the doubt that the research is accurate and truthful, we should be able to start forecasting based on antipodes alone. So I'm looking at an earthquake. I don't see a 6.5, but you know what? Let's just try this. Let's look at this 6.0 that struck in Indonesia, and let's see what that antipode is. What is the antipode of this location in Indonesia? 6.0. Yeah, it's not a 6.5, but let's just try an antipode forecast with a 6.0. So this was September 19th at 7:32 UTC time, or basically 12:32 West Coast time, Pacific Standard Time, I should say. Let's see if we can find that antipode. It looks like it's in South America somewhere. So we've got to get to within 30 degrees of this point in South America. So we're going to be, if we're within 30 degrees, I'd say we're in this general area up here. So we are looking for an antipode quake, and let's see if we can find one. So that's a 6.0, Sumbersari, Indonesia, September 19th. What do we have over here? No, that's the 14th. What do we have over here? That's the 16th. Okay, so we're going to go ahead and forecast a 5.0 or greater. I know I'm not using a 6.5, but there's no 6.5s on Earth right now over the last 7 days. So let's go ahead and use this 6.0 and see if we can forecast a 5.0 in South America. And we're looking for Colombia, Peru, Ecuador, Venezuela. We'll take any of that. So we're going to be looking for a 5.0 or greater over the next 2 days. So I'll be back in 2 days to see if we got an antipode hit. I'll take a 4.8. I'll take a 4.9. That's okay as well, since 6.5 is, fell to a 6. I guess we can do a 4.5. Let's do 4.5 or greater. And we'll do that over the next 48 hours, and I'll be back to see if there's any truth in this article. Let's see if we can find it. All right, with that said, I'll sign off.